Hey friends at Ingalls. Hey, I'm actually doing my lesson not with my class because I did a Google Meet and I didn't hit record or something didn't work. So I'm trying it again. I wanted to go over a couple of things with you guys. We're gonna do 4.2. We're also great job on your tests. Woohoo! You did well. I will get those if you haven't seen them already in your email. You should be getting them soon. And so I this is Monday night, and I should be able to get them done tonight. So anyway, I'll be sending those out along with the key. And again, if you guys have any questions, once you look at my notes, if you think one, I took off points where I shouldn't have, or maybe the explanation wasn't where it needed to be, I would be happy to meet with you, or email me because honest guys, I do make mistakes. You probably have realized that by now, but let's go ahead and get started. Today we're going to go over 4.2, which is our logarithmic functions. Now, when we do this, I want to start also with a review of a 4.1, which is our exponential, because they are tied together like like crazy. So what I'd like you to do on the underneath in your classroom in college algebra, you will see that I have a Desmos activity. If you click on that, you should get this worksheet that pops up. And so what I'd like to do is um, go ahead and go and explain what I'd like to have done on this one. This was kind of really going to be on 4.1, but it's also going to carry on into 4.2, okay? So with that, there is a Desmos link that you can click on. So when you click on that, it should open this picture right here. And what it is are two sliders, or two equations that I have put different sliders on so that you can manipulate and change the function. I want you to start off by taking off, like unselecting the color for 6, and that just shows it. We're going to come back to that in a second. Now, if you notice on your worksheet, the very first one equation was y equals 2 to the x. And notice out to the side, it says a equals 1, b equals 2, and c is equal to 0. And that's going to correspond right here with the sliders that you have. So again, I'm going to let a equal 1, and you can change that again by just doing that. And notice it's going to change my my function just a little bit. Oh, I also need to have it selected. So let me go ahead and select that sucker. Okay, let me go back to here. So when I select A, by changing A, the value of A, notice if it goes negative, it's going to go down. If it's a positive number, it's going to go up. We kind of discussed that a little bit. But I'm going to let you put those values in for where the worksheet is. So A is going to be 1, B is going to be 2, and C is going to be 0. And so when I do that, let's go, B is going to be 0, or B is 2. Goodness gracious. All right, there we go, 2. And then C is going to be also 0. So I'm going to just make that one 0. And then you notice then you'll have a function, and I can zoom in on the function, but I wanted you to go ahead and identify a few things. I'm going to ask you to identify what the value is when x is, oh goodness, C changed. When did that change from 0? I had it to 0, I swear. There. I think I went and moved it. It jiggled. So when x is equal to -2, I want you to zoom in at least and find out what the value is. And if you click on it, you should be able to get it exactly right on a few points. And notice that it's going to be 0.25. But remember, this is actually 2 to the -2 power. That means it's actually going to be 1 over 2 squared, which is also 1/4, hence 0.25. So if you put 0.25, I'll accept it. If you put 1/4, I'll still accept it. So just to let you know, that's kind of what I'd like you to do. On the next one, if you notice, I have 1 and 0.5. Again, 0.5 is the same as 1/2. It's also 2 to the first, 2 to the -1 power. So that's how they're getting that 1/2. Then notice then I've got the point 0, 1. So again, what I'm talking about is that on this t table, I'm going to start filling in these values here. This is going to be 0.25 or 1/4. This one is going to be then 1/2 or 0.5. When x is equal to 0, We'll always, 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 in this case, unless there's a shift, have it be 1. And then if I go back to my function, when x is equal to 1, I should have the value of 2. So let me see if I can kind of scroll where I get there. There it is. And again, and when x is equal to 2, I should have the value of 4. And I made those points, I made my base on all of this worksheet too, just because keep in mind, if I had it be 3 or 4, it's going to get big really fast. So when I have 3 to the second power, I'm already up to 9. If I have 4, it'd be 16. 5, it's going to be 25, etc. So again, that's why I chose my base to be 2. And then I want you to take a picture of this. Now, the way I take a picture of this is going to be the Shift Command 4, and that's on my Mac. But then I highlight what I want, and then I take a picture of it. It's going to take a screen. I know if you have a Chromebook, you're going to need to go ahead and probably do a screenshot. There should be a button at the top that helps you with that. And then what you want to do is you want to go to here. I'm going to just go ahead and delete this one out because this is mine. Okay, I want your cursor to be inside the little graph table box. And then I want you to tell it to insert. Let's see if I can, come on, don't be, okay, should be under Chrome. Oh man, I think I've just got so much open. Maybe, I don't know. Usually I have it right here. Oh, it's under, it's huge. That's why. Sorry. Okay, I've got my cursor in my box. I'm going to click insert. I'm going to go image from my computer. And then you should get something that's similar to that. And you should be able to select that graph and then just go ahead and tell it to put it in. And then you should be able to then go ahead and uh, go ahead and fill out your chart. And that's all you really need to do. But notice that on the second one, I'm going to change, and I've got the values of A to be 1, B is going to be 0.5, which again is 1/2, and then C is going to be 0. So I'm going to come back over to my graph. I'm going to change the B to 1 or 0.5, which is 1/2, and notice what happened to my graph. It's now, as instead of getting really big, when X is going to get to go to the positive, then the Y was really increasing fast. Well, notice now as X gets really big, it's going to start approaching that asymptote of my my X axis. And so you're going to do the same thing with your worksheet that we just did on the other one. You're going to fill in those points. Notice it's going to be switched this time, because if I do -2, I'm going to come over here, look at -2 is going to actually be then the value of 4. Okay, and so I want you to kind of play with the graphs and just show you a little bit about what the graphs do for exponential as well as logarithmic. Yes. All right. So with that, that is an assignment. I'd like you to at least get by the end of the week, okay? I'm going to ask you to get down to number 4 done. We're going to actually talk about the logarithmic functions, which starts with number 5. And so you might be able to get it done sooner. But anyway, I'm trying to give you plenty of time to get that done. Then with our lesson today, we're going to go back and we're going to also talk about logarithm functions. So our logarithm functions, let me see if I can get it so that maybe my picture's not where I'm going to want to talk. Let me go over here because I'm kind of done with that. Kind of done with this. All right. So I know that when I originally taught Algebra 1 or Algebra 2 with I think it was Savas, they had it actually written as like the exponential form as b to the m is equal to n. And then the logarithmic form, remember, the logarithms are just exponents. And so what it was then, it would be m is equal to the log base b of n. And it is really all you need to know is that those are going to be variables and you can change. Now, what's constant in this is that we're going to talk about a base. And when I have a number to a power, it's that number that I'm taking to a power is the base. When I have a logarithm, it reads also as log base b of x. And so then this number will also be the exponent always. Okay, and so whether or not you use it like with the m and the m's, or the way our book is going to do it, they're going to put it into x and y. And so the y is going to be your exponent, so y equals log base b of x is the logarithmic form, but the same form, these are equivalent to each other. These mean the same thing, and you can just, there's times we want to use one over the other one just because of ease, but then on this one, it's going to be b to the y, because remember, that's the exponent is equal to x. Now, what that means is that when I have an equation like this, okay, and they said write the equation in the equivalent exponential form. So this is in logarithmic form, obviously, because it has a log. This is going to be my base, so I'm going to say 9. Remember, this is going to be my power, so 9 to the second power is going to equal x. And then obviously, if I have 9 to the second power, I want to change that to 81. So that means it's 81. So really, when you have 2 equals the log base 9 of 81, that means that you're saying 9 to what power is going to be 81, and then you would, again, that's going to equal then your exponent, which is 2. Okay, just I want you to get so good at this. So I've got a Quizlet form, but I'm going to also do a couple ones. Let's just do, say, another one. I'm just going to write it as the log. So log, let's say that I have log base, uh, now I just went totally blank. 4 is equal to 16. Again, this is going to be 4 to what power is going to be equal to 16. And you would say, well, that has to be 2. So for log base 4 of 16 is equal to 2. Know that I'm also going to write sometimes it's just a common log. And a common log, and in a second, we're going to know that we're going to talk about it further, is going to be has a base of 10. But if I know that I have a log base 10 and I have, in this case, say 1,000, then this is going to be then 10 to what power is equal to 1,000, and then you're going to be equal to 3. I'd love to know how many of you guys are on Quizball, because you're going to see, these are great ones to see when you have Quizball questions. Okay. When we do this, we're going to continue practicing, and you guys are going to be so good at these by the end of the day. I just have a feeling. Okay, on the next page, what we're going to do is we're going to go from equation form to logarithmic form. So again, remember the 8 to the power, that has to be my base. That's going to be b. So this means log base 8. Remember, the y is going to be the exponent of 3. So in this case, it's 300 is equal to y. Now, we're going to be able to do this by the end of the unit. And so in this case, this is as simplified as you're going to get, because you're saying 8 to what power is going to be 300, and there's not a whole number that'll make that work. But I could also, anytime you have a problem, like in this case, let's say that I had, say I was given something more like 2 to the fourth power, or 2 to the y power is going to equal then 32. And so in this case, remember, this is my base. This would be the same as log base 2 of 32 is going to equal y. Well, this is actually a number. So 2 to the fifth power is going to be 32. So then y is equal to 5. Okay, so you would simplify that a little further. Now, these are the ones that we're similar to what we just had. So in this case, if I have log base 3 of 81, then I'm going to simplify it. This tells me I'm going to start off with the base, which is 3. 3 to what power? And I'm just going to go ahead and do real quickly just a box, because you're going to fill in that box, is equal to 81. Now, a couple of things you could do is you can start thinking of 81 is the same as 3 to what power, or you can just go ahead and say, well, I'm going to start with 3. I'm going to go 3 times 3, that's 3 to the second. Times 3 is going to be 3 to the third, times 3 to this 3 to the fourth. And so this, in case, this is going to equal then 4, because 3 to the fourth power is equal to 81. And we know that's going to, when we write it as a logarithm, it's going to be the exponent. Now, when it is going to be 1/9, what you're asking yourself again is 3 to what power is going to equal 1/9? Well, in this case, I know 3 squared is 9, but how do I get it on the bottom of my fraction? Well, remember, that's got to be a negative number. So in this case, 3 to the negative 2 power is going to equal 1/9. And so this then is going to equal then negative 2. When I have a base that's larger than what I'm looking for, then I know I have to be looking for a root. So again, over here, I knew that I had to have a negative number because I had a fraction. This one's going to tell me because the 81 is larger than 9 that I'm going to look for a root. So this reads as 81 to what power is going to equal 9. Well, I know 9 squared is 81, so that means that 81 to the square root of 81, or 81 to the 1/2 power, is going to equal 9. And so this is the log base of base 81 of 9 is going to equal then 1/2. Now, a couple of rules that you're going to use a lot. So I keep saying that, don't I? So anyway, on this one, if you have log base b of b, if your base and your number are exactly the same, then it's always, always, always going to equal 1. For instance, what they're saying, I'm going to come back to this one in just a second. If I have log base 3 of 3, okay? Think about that. I'm saying 3 to what power is going to equal 3? Well, this is going to be 3 to the first, so that means it has to be the value of 1. 3 to the first power has to be equal to 3. And so anytime your bases are the same, okay, as which the number you have, like your log base b, or which is 3, is equal to the same number, then it's always going to equal 1. Now, the same thing kind of goes when you have it equaling 1. So again, let's just keep that, the log base 3, and this time I'm going to say of 1 is equal to what? And so this is telling me I have 3 to what power is equal to 1? Well, I know this has to be 3 to the 0 power, because anything to the 0 power is always going to be 1. So anytime it can be any number back here, but if you have a 1 inside your log, this is always, always, always going to equal 0. Hence the problem we have right here. So log base 6 of 1 means I have 6 to what power is going to equal 1? Well, you know it has to be 0. So this is going to be 0. And so again, anytime the number is the same, log base 25 of 25, whenever those are the same, that's going to equal 1. But if I have log base 25 of 1, it'll always, always, always be 0. Okay. Then the next problems that we also have a different property. Okay. If we have, in this case, a log base b of b to the x. Okay. So in this case, let's just do that a problem. I'm going to break it up just a little bit. Let's say that I had log, remember the one that we had before, when we had log base 4 of 16. Okay. So log base 4 of 16. Well, I could change that to log base 4 of 4 to the second power, correct? And so what this is saying is that this is just going to equal then 2. And it kind of makes sense because when I had log base 4 of 16, which is, you're saying 4 to what power was 16, and that means you know that that was going to become 2. So what they're doing is they're just changing this and this number here to an exponential form, a base with a number. And it happens when the two bases are exactly the same, it's going to equal that x value. If I have a number, a base, but the exponent is also written as a base of b to the x, then that's also just going to equal x. So let's just replace it. Let's just say that I happen to have, I'm going to make that, hey, how about the number of, let's go 20. So I have 20 to the log base 20 of x, then that means that this is just going to equal x. So if these two numbers are exactly the same, then it's going to equal the value of what you're taking the log of. So going back to this one, so log base 4 of 4 to the 6, that means that I'm just going to have the 6. If I have a log 7 to the log base 7 of 23, that means it's just going to equal then 23. Now, this next part is going to get into where we have what it looks like when we have a graph. This first part over here, Okay, this is the exponential equations that we did on 4.1. So we have f of x is equal to b to the x. I think we did on our problem 5 to the x power. And remember, when we had 0, comma 1, we had, when x was equal to 0, we had 5 to the 0 power, and that made it 1. And then you notice when x is equal to 1, it went to 5. When x is equal to 2, x was 25. But then as it got to the negative numbers, we'd have x to the 5 to the negative first power was 1/5, and then we had 105 to the negative second power, which was again getting smaller and smaller, but it was never quite hitting 0. So this is what the graph looked like from 4.1. Today, what we're going to do is we're going to change that same value, but make it into a logarithm form. And so what happens that these are going to be inverses of each other. And inverses, remember from the last chapter, had a couple of properties. One, they had to be symmetric about the equation y equals x. Okay, and in this case they do. They also, if you remember, all the x value, the x and the y values, all they do is switch. So if I have the point 0, comma 1, my inverse will have the point 1, comma 0. And same thing goes on this one. Instead of having an asymptote like we had from 4.1 when the x-axis was my asymptote, this time is now my y-axis is going to be my asymptote. Also, remember my domain and my range on all the inverses, they switch. So again, we have kind of some interesting features going on. We also did, if you remember, what happens when our bases, now this one was the one where the base happened to be, I know in our example we did, it was 5 to the x power. Then we did 1/5, and we showed what happened, that it's actually going to flip, and it kind of becomes higher here, and it also goes down. Notice too, that's also kind of what I'm wanting you to do when we change like our base. Remember, the base is going to be, let me make it 2 here. 2, and notice that it's a curve that's going up like this way. But notice if I change it to 0.5, see if I can get it to 0.5, which is 1/2. Gosh, I'm having a hard time grabbing, just going one little. Oh my goodness, it's going everything but 1. There's 0.5. Okay, so then this is actually showing it's flipped. And so that as x gets really, really big, now it's going to go and closer to your asymptote. Your inverse also, when your base is going to be, again, a fraction, this is what your logarithm function is going to look like. And we're going to show that on the second part, like 5, 6, and 7 from the worksheet that we have. But with that, that means that we can graph all of our problems. So the very first one, they start off and they say, well, graph g of x when it's equal to 1 plus x, a log base 2 of x. Now, when I do that, the same way I can write this, usually I'm going to I put the plus 1 of the end. So I'm going to go log base 2 of x plus 1 is the same thing, okay? Now, in this case, if I have a log base 2 of x and I'm thinking about all the values that I have here, I could also go to my Desmos. Whoops, sorry. And I could go ahead and let each of the values that I'm given here. So in this case, my base is going to be 2. Okay, this time the value of A is still going to be 1, but the value of C is also going to be plus 1. So it's going to be shifting up. So this is the graph of what I see right here of log base 2 of x plus 1. How you can also get that is just knowing what your log base 2 is. Oh, whoops, I did the exponential one. Sorry, hold on. Let me change it. I was going to say it's going the wrong way. That's because I did it over here on my logs. Notice on this one, I went ahead and I have D, F, and G as just my variables. The reason I couldn't use an E is that E represents the number of the natural log. And so in this case, the D would be then the 1 that we would want. Let's see if I can get D to equal 1. Then on this case, the base, log base 2. So there's my 2, and then G is going to be then plus 1. This is the equation that I will see from my worksheet. So this is what this one will look like. And so notice that if I just have the the parent function, which is log base 2 of x, that means g would have to equal 0. This is what it looks like, where the value of when x is equal to 1, y is going to be equal to 0. And then when x is equal to 2, y is going to equal 1. So I'm going to pencil in what my parent function is. And this one, again, is f of x is equal to the log base 2 of x. But then if I want to go ahead and do my g of x, that's when I'm going to have it shift 1. So that means I'm going to make g equal 1, have a value of 1. And notice then all of my points then are going 1 higher. And so my graph then shifted 1 up, and it would be then my orange. So my orange one would be the +1. Remember, this is going to be an asymptote, even though it's kind of looking like it's hitting that line. Okay, when I talk about the function's domain and the range, so let's look at the orange value here. If I had a function's domain, that means if notice I'm getting very, very close to 0, but I'm never hitting it. So my domain would be from 0 to infinity. Remember, it's not ever going to hit 0, so it has to be a parentheses. And then it also have a parentheses on this one. Notice on my range, I can have any value for y. So it's going to be from negative infinity to infinity. And notice that this was the opposite when I had my exponential functions. And so again, going back to one of the properties of our inverses. Okay, so the next one, we're going to get into the common logs and the natural logs. And so my common logs, again, another way you won't see this written, but this means log base 10 of 1,000. And so we know that this is saying 10 to what number is going to equal 1,000. And you would say, well, 10 to the third power has to be that. So that's going to be the value of 3. You can also, on your log functions and your ln functions, you can also use your calculator real easily. So on this one, I'm going to go log of 1,000, and then I'm going to get 3. Notice too, I can also go the log of a small number. If I have like 0.01, so this really could mean the same as the log of 1 over 100th. So 1/100th would be written as a fraction as 1 over 100. So that means that that's 10 to what in power is going to equal 1 over 100, which has to be then -2. And again, you can still do that on your calculator with a common log. So 0.01 is going to give you -2. You could also go, again, log of, clear, I went ahead to me parentheses, log of, and then I'm going to go 1 divided by 100. And that's still going to give me -2. All right, in this one, this is a property that we had. So if you have 10 written as to the log of 53, remember that's same as that's log base 10. And so when these two numbers, when I have 10 to the log base 10, which again is assumed of 53, is just going to be then 53. And that came back from our property that we had before. So this time we're going to have your instructions are right here. You're going to transform the graph. Sorry, I didn't get there. So in this case, I've got a transformation of my graph. I have a negative log of x and then +2. I would again, since I've in that same form, I would have gone a negative log of x. Remember, it's base 10 of x and then +2. So my parent function is right here. So it's log base 10 of x, but it's going to be negative. So in this case, if I come back over here to my graph that I have, that I have the sliders on, I can let D equal the -1 because that's what it has a negative in front of it. Then I know that my base, in this case, I'm letting F represent my base, and it's going to be represented by 10. See if I can get it right there. And then G is going to be then +2. So what it's adding this 0.2. So that's the graph of this function. Notice that the negative will allow it to go all the way up. And notice also that without my shift of G of 2, let me make that G back to 0 again, because that's just a shift going up. Notice I have the same point of 1 comma 0, but that one is shifted up 2 places. Okay, so I have 1 comma 0 for my parent function, and it's flipped because it's actually going closer as x gets smaller and smaller. It's getting closer and closer to 0, but then it's going to go over here. Now again, this is going to be the graph of my parent function. So this is going to be y equals a negative log of x, okay? But then to do the shift of 2, that means I'm just going to come up 2. So to get this one, then I'm going to go up 2. So every point here, I'm just going to go up 2, and it's going to be then the same shift. Now remember, it's going to cross here, and it's going to kind of continue on just like it did before. The next lesson I have I'm going to do is we're going to get into the homework assignments, and I'm going to show you a little bit on how to graph some of those from your homework. So natural log is going to be base E. So this actually could be written as log base E of e to the 7th power. You won't ever write it that way because the log base E is the ln function, but that's what it means. And so in this case, if I have an e to the e power, that I know that it's just going to equal 7. So when I look at the ln of ln, not m, of e to the 7th power, that means it's just going to be 7. When I have a function within a function, so if I just look at my parent function, which is going to be y equals the ln of x, that means that I have then the value. I know it's going that same shape where I have 1 comma 0. Then when x is equal to 2.7, about 2.7, because that's the value of e, the value of y is going to be 1. So it's going to resemble this. But then in this case, if I have the function within my function, that's going to tell me I have a shift for g of x. It's going to be shift, let me put it in, shift of 1 to the left. Okay, and so in other words, I'm going to come over here, and it's also going to shift my asymptotes exactly the same way. All right, that does it for my assignment. You guys have a couple of things to do. So anyway, good luck. Let me know if you have any questions.